In this video, we are going to talk again about nitrogen and its compound using our flowchart diagram here. So we have done several questions, and this is still another question, and this is to help you understand the whole topic and the concepts that are important for you, that are tested in your exams. Okay, now let us start. So we have a compound R here, and you can see your compound R is being formed from two substances, which is ammonia and nitric acid. Now, let us mention something. Let us remind ourselves something before we proceed to the question. Now, how do you form ammonia, or how is ammonia formed? Ammonia is formed from the reaction of two things, which is hydrogen and what? And nitrogen. Okay? Now, the lab preparation of ammonia, when you're talking about, so we have three methods. So we have three methods of where you can form your ammonia. So ammonia can be formed by from three methods that I'm going to mention below. One is you can form it from decaying organic nitrogenous materials. Okay, should I write maybe here? Can you see here? By you decay what? Decay organic, by decaying organic nitrogenous substances, okay, or materials. That is one method of forming ammonia. The second method of forming ammonia is reacting a metal nitride with water. Metal nitride plus what? Plus water. Okay, that is another method of forming ammonia, a metal nitride with water. Now, another method that is used in formation of ammonia is what? It is simply decomposing a mixture of ammonium salt and an alkali. So here you decompose a mixture of an ammonium salt and an alkali. Remember, an alkali is what you call a base. So in this case, you can talk about, like for example, when you're talking about a metal nitride, we are simply talking about maybe potassium nitride, okay? But we are not talking about gold, and the exceptions are gold and platinum, okay? Now, when you're talking about ammonium salt, you can simply talk about ammonium chloride plus a base like what? Calcium oxide. Okay, so that is how you form your ammonia. Okay, now, and we also said ammonia, because it's made up of nitrogen and hydrogen, where do you get these two components or two products or substances? Now, nitrogen, you get it from fractional distillation of liquefied air. We have done it, okay? You can check it out in our videos below. And hydrogen, you get it from cracking of long chain alkanes, and also you can get it from electrolysis of brine. So that is it about ammonia. Now, nitric acid, let us come here. So we have ammonia here. So this is ammonia. And here you have your nitric acid. Ammonia and nitric acid are going to react to give us a compound R. Now, what is our compound R? So let us write the reaction that is going to be there. We are going to have ammonia and our nitric acid, okay, reacting to give us an ammonium nitrate, okay, which is going to be HN4O3, okay. So our compound R is ammonium nitrate. So we have solved that one. Now you can see the ammonia is reacted with oxygen and water. Step one, it's reacting ammonia with oxygen. And then the product you have formed, you react it with water for you to form nitric acid. So what does this mean? This simply means two things. That ammonia is undergoing what? Oxygen, you're going to talk about what? Catalytic oxidation. This means that our ammonia is undergoing catalytic oxidation, okay? Catalytic oxidation, meaning that the reaction that is going to be here, it is your ammonia, I hope you can see here, ammonia plus oxygen, okay, to give you nitrogen 2 oxide plus water. Okay, and when you balance it, you balance by putting a you balance by putting a 4 there and a 5 here. Let me put a 5 there, and you balance by putting a 4 there and a 6 there. So this is catalytic oxidation. Now another thing that happens is during the formation of your nitrogen 2 oxide, it further again gets oxidized. It is catalytic oxidation. So your nitrogen 2 oxide is going to be further oxidized to form what? Nitrogen 4 oxide. I hope you can see, yeah? Now, when you're going to balance, you said you balance. So you're going to balance by balancing the number of oxygen atoms present. So it's going to be 2 here and it's going to be 2 on that side. So we have formed our nitrogen 4 oxide in the first ammonia plus oxygen. After you have formed your nitrogen 4 oxide, this water means that our nitrogen 4 oxide is going to undergo hydrolysis. Okay, hydrolysis is simply what? Reacting our nitrogen 4 oxide with water. As you can see, these questions are just flowchart questions, but they're repeating themselves all the time, because I believe the main thing that they're testing is if you know the formation of ammonia, the formation of nitric acid, which is the whole Ostwald process, as well as what? The formation of your nitrogen, which is a part of ammonia, which is what you call fractional distillation of liquefied air. Now we are going to form our nitrous acid plus our HNO3, which is our nitric what? Which is our nitric acid. Okay, now that is how you end up with your nitric what? You end up with your nitric acid. Now, the nitric acid undergoes a step 2 and you get aqueous potassium nitrate from it. This means what? You can see potassium here. Potassium is what? It is a metal. This means you are testing the chemical properties of nitric acid, which is now an acid. You react it with a metal. If you react an acid and a metal, what do you get? Acid plus metal, what do you get? You get salt, which is metal salt, okay? And hydrogen what? And hydrogen gas. Now, this means the metal that is here, it is potassium, because you cannot end up with potassium nitrate without the potassium metal. So the reaction that is there is HNO3. You react it with your metal, which is your potassium. Sorry. To give you your salt, which is potassium nitrate, plus your hydrogen what? Your hydrogen gas. So that is what is happening in step 2. In step 3, you see your acid. Now this whole part from here going downwards, we are testing the chemical properties of your nitric acid. One is reaction with metals, you can see. Now this one is reaction with hydrogen sulfide. Now what is happening here? Here they are saying, we said nitric acid is an oxidizing agent. This is an oxidizing what? It is an oxidizing agent. So what will happen? Oxidizing agents get reduced while they oxidize the other substance. So nitric acid is going to be reduced and it is going to oxidize what? It is going to oxidize the sulfur. Now the reaction that is going to be here, the process is you have your nitric acid, you react it with your hydrogen sulfide. We've said it is going, so this process is, step 3 is what? It's a redox reaction. Redox meaning, if you see redox, you see you have a reduction oxidation process. Reduction OX oxidation. Okay, so the nitric acid is going to be reduced and the sulfur is going to be oxidized. In this case, hydrogen sulfide is going to be oxidized. So the products are going to be nitrogen 4 oxide, okay, plus water plus sulfur. And you balance by putting a 2 there. Now, this is the step 3. Step 3 is a redox reaction, and you lead to the formation of that. Now here it is nitric acid with a metal, again reaction between acid and metal. This solution P is formed from the reaction between nitric acid and copper. Okay. So when they react, you're going to form copper 2 nitrate. So solution P is our copper 2 nitrate. Okay, you're going to form copper 2 nitrate plus nitrogen 4 oxide plus water. And we are going to balance by putting a 2 there and putting a 2 there and putting a 4 where? A 4 there. So we see we are having our solution, which is copper 2 nitrate. You heat it. This is thermal, or they're testing the decomposition of nitrate salts. So when you decompose a nitrate salt, what will you form? So you see one of the product is copper 2 oxide. That is it for the lesson.